Adjunct Professor Moran, Microeconomics 112. In our continuing discussion of types of business competition, in the last video we began to discuss oligopoly, when production is characterized by few producers either making an identical product or a differentiated product. Competition is limited to a few competitors because of high barriers to entry. Could be because of advertising costs or cost of production. So we're now going to discuss game theory. So game theory is a tool used in the study of how people make strategic decisions. Strategic decision is when what you do affects your competitor and what they do affects you. Unlike pure competition, when there are so many competitors, each one is an infinitesimally small part of the whole. It's kind of like chess. If you make a move, you have to anticipate what the other person is going to do, and vice versa. So oligopoly exists when there are barriers to entry that restrict the number of competitors to just a few. This leads to a situation called mutual interdependence. In decision making, the best outcome for a firm may be impacted by what the other company does. So before you decide to do something, you have to anticipate what the other company's action will be and its consequence on your outcome. As a result, collusion or reaching an agreement not to compete by dividing the market may be mutually agreeable. So, because there's few players, you can coordinate amongst yourselves and try to rig the system. Game theory is an attempt to explain these strategic decisions in an oligopolistic industry, where it's possible because there are only few competitors. Game theory wouldn't apply to pure competition or monopolist competition because there are many competitors. A monopoly, there's no point, there's only one. We're going to assume that each firm lists its best and worst outcome. So in these simple forms of game theory, there's only two outcomes for each player, giving a matrix of 4, as we'll see in a minute. Each participant attempts to reach the best outcome for itself. As a result, exclusive agreements may break down if the strategy for each player doesn't reinforce the strategy for the other player. It's called no honor among thieves. Because these collusive agreements can't be enforced in court because they're illegal. It's against the law for business to cooperate in an uncompetitive manner. Payoff matrix is when there are only two outcomes. It's a 2x2 square that summarizes what's going to happen based on each player's choice. Here's a payoff matrix. Here's a company called Rare Air. They can go high on advertising, low on advertising. Uptown can go high on advertising or low on advertising. It's row. The numbers are row, then column. So it's Uptown first, and then Rare Air. Uptown, Rare Air, Uptown, Rare Air, Uptown, Rare Air, Uptown, Rare Air. Payoff matrix. Now, there's a dominant strategy and a dominated strategy. The dominant strategy is the one that results in the best outcome regardless of what the other player is doing. And a dominated strategy is an outcome that results in a worse decision, in a worse outcome based on what the other person does. A Nash equilibrium is a combination of strategies for the two players that results in the best outcome for one given the other's response. It may not result in the best out for society. The best out for society is when you add these up and the number's highest for the two players, but it may not be the one that results in the best outcome for each individual player, although in this example it will. We're going to do another example later where that will be the case. So let's just do this very simple example. If Uptown advertises high, Uptown has a choice of advertising high and advertising low. Rare Air has an opportunity of advertising high or advertising low. If they both advertise high, they'll both end up with profits of 12 for a total output of society of 24. If Uptown goes high and Rare Air advertises low, then Uptown will get 15 and Rare Air gets 6. But if Rare Air goes high and Uptown goes low, then Uptown gets 6 and Rare Air gets 15. If they both go low, they'll both get 8, resulting in an outcome for society of 16. So you can see that these players, the best outcome for society is 24. All right. Now, how does this work? The way you want to summarize this is you want it for Uptown. Okay. You want to set it up kind of like this. Okay, we need more. Let's do it this way. Okay, that's better. Uptown's thinking, well, should we go high or low? So they're going to think, well, if we go high, what's rare air going to do? What happens to us if we go high depending on what rare air does? So Uptown's thinking, if rare air, the competitor, goes high, then they're going to say, well, what are our choices? So if rare air, the other player, goes high, then Uptown can either go high or low. Uptown's trying to figure out what to do. If rare air goes high and Uptown goes high, then Uptown gets 12. If rare air goes high and Uptown chooses to go low, then Uptown only gets 6. So if rare air goes high, Uptown should go high. But Uptown's thinking, well, what happens if rare air goes low? Well, if rare air goes low and Uptown goes high, if rare air goes low and Uptown goes high, Uptown gets 15. If rare air goes low and Uptown chooses to go low, then Uptown gets 8. You can see that regardless of what rare air does, go high or low, Uptown's better off by going high. So that would be a dominant strategy for Uptown, to go high, because no matter what rare air does, Uptown achieves a better result by going high. In this example, the same thing will happen for rare air. So rare air is trying to decide what to do. So they're thinking, well, what's our opposition's choices? They can either go high or low. Well, what happens if Uptown goes high? What are the two outcomes for rare air to respond? If Uptown goes high and rare air goes high, if Uptown goes high and rare air goes high, then rare air gets 12. But if Uptown goes low and rare air goes low, then rare air only gets 6. So if Uptown goes high, rare air is better off going high also. But if Uptown goes low and rare air goes high, rare air gets 15. If rare air goes low and Uptown goes low, then rare air gets 8. As a result, again, similarly, rare air's dominant strategy is to go high, because no matter what Uptown chooses, rare air is better off going high. So the dominant strategy is going high, and the dominated strategy is going low. There's also something called a Nash equilibrium, and that's a combination of strategies for the two players that gives the best result for one, given the other's best response. In this example, Nash equilibrium the Nash equilibrium is both going high. They'll come to like an equilibrium there. There'll be no incentive for Uptown to change or rare air to change. In our next video, we're going to continue to practice with this with a different example that's a little more complex. Oligopoly and game theory.